this, and the moral of the story is this is not balanced, right? So this was, again, just kind of going over the homework, but we do need to understand particle diagrams today, so this is good. Here's our Mickey Mouse. Remember, water's Mickey Mouse. Okay, it's not balanced. Okay, we have two red, two yellow, one yellow. So you guys wrote it down. What do? I have to add another, right, Jake? You with me?
Yeah.
Okay. And now we need another water, right? So we already did this. So I'm just reviewing, kind of, right? Everybody with me? Okay. And the way we show this on paper is big numbers in front called coefficients. Okay? That's a coefficient. I need 2 hydrogen molecules, 1 oxygen molecule, and that will create 2 water molecules. That's called a balanced chemical equation. Mass is conserved, so is charge. These two have 0 for their charges. This is +1 and -2. That adds up to 0. And energy is also conserved. All right, again, that one you're going to have to just take my word on it. All right. So if I had 100 molecules of those and 100 of those, how many of these can I make? Well, let's make it simple. Let's say I have 2 and 2. What if I have 2 waters and 2 oxygens? Can I make more than 2 water molecules? No, because these 2 are here. I thought that would work. Stay. Okay, and then these 2 are here. And then these 2 split. One goes here, one goes here. Right? So we already did that. I'm just trying to kind of show you the action of it. What's left over? Oxygen. Who remembers what that's called from last week? One of these is called the limiting, and the other one is, go ahead, guess. One's limiting, one's, what's the other one?
I don't know the other one.
Oh, what's the other one? Excess. Jake, which one's excess, which one's limiting? Did you have your coffee today?
No.
Oh, well, that's the problem, right? Must be. Someone help him out. Higgy. Yes, because it's gone. Limiting means it's gone. Excess means there's extra. Okay? So, the point of this, lots of points here, but the point I'm trying to make is if you have the same number of both of these, will they both react completely? No. So if I have 100 of these, how many of these can I make? I just had 2 of them. How many waters did I make? 2. So if I have 100 of these, how many of these can I make? 100. How many of these will be left over? If I had 2 of these and 2 of those, you just watched what I did, right? I mean, I can do it again. I can back it up. So if I have 2 of these, right? 2 of those and 2 of these. So if I have equal amount of both, 2 and 2, I can only make 2 of these. They're gone. That's gone. And 1's left over. So instead of 2 to 2, it's 100 to 100. All this is gone. How much is left over? 50. Very good. Okay? So the point of that homework assignment was for you to understand balancing equations, conservation of mass, and excess and limiting, which is not a Regents thing, but it's really, it would be like a disservice to you if I didn't at least explain it a few times this year, what that is, okay? Especially if any of you want to take AP Chem, that's a really important concept. So excess and limiting. All right, so that was it. That was the homework problem. I never really went over the actual question. I just kind of went off on the balancing and all that stuff, all right? So that was conservation of mass, and again, the point of balancing is so that you have the same number of atoms on both sides, right? And if you have the same number of atoms on both sides, then the mass will be the same. So just one more time, let me make it very clear, and then we'll move on, okay? So if we have 4 H's, that's 4, let's say, grams, right? Let's say those numbers are in grams. If we have 2 oxygens, that's 32 grams. So this side of our scales, right, is going to be 36 grams. Well, if I have 4 H's here, there's my 4 grams, and then 2 O's, there's my 32 grams. That's 36 here, 36 equals 36, conservation of mass. That's why we balance, and that's why I'm teaching you it, and that's why I'm starting to use these magnets so you understand how to draw these pictures. That helps understand, right? Particle diagrams. Okay. All right, we're going to leave that alone for a minute as far as the diagrams are concerned. And I want to just finish talking a little bit about temperature. So we talked about conservation of energy, thermal energy. We should have written this down. What creates thermal energy? Raise your hand. Particles in motion, right. The faster they move, the hotter they get, okay? And there's different types of energy, and we're going to talk more about that down the road. But you have thermal energy. I just explained in here there was chemical potential energy. So when you eat food, where do you get the energy from? I mean, if you don't eat, you're not going to have energy, right? If you don't sleep, you're not going to have energy. You need to do those two things to get energy. Where does the energy come from? Okay, let's think big picture. Where does everything on this planet get energy from? The sun. Okay, you do not have to write this down. You can just watch. Here's the sun. Here's Earth. Okay? And that's way too big. It would be smaller. But anyways, there's Earth. So all the sun is hitting Earth. Okay. And then here we go. Now we're on Earth. We have people. Okay, we have people. We have animals. That's a cat. Okay. We have, I don't know how to draw crops of some kind. Oh yeah. There you go. There's trees. And this is corn. Okay. All right. So, we have food we grow, we have trees, we have animals, we have people. Okay, where am I going with this? Right, conservation of energy, and this is going to lead us to temperature. Okay, so the sun has all the energy, it's giving it to Earth. Okay, everything you see here, everything on the planet needs sunlight, basically. Okay, sunlight is a form of energy. Without sunlight, can my beautiful corn and tree grow? No. So the sun gives the corn and the trees and whatever other crops you want to think of energy. Animals eat these things. We eat the animals, or we just eat the vegetables, right? So the energy is really from the sun going into the plants and animals. We eat plants and animals. How do we get that energy?